Let's have a look at these configurations. I'll actually pick up 3 routers. One, 2, and 3. So I pick up 3 routers, okay? And also I have switch. Okay. So this is the switch. And then we pick up the PC. So similar sort of configurations we have done with the other labs, so it will be similar, but we have one more extra route in here. Zero, 1, 0, 1. Okay, 0, 0 is left only. That's fine. Now this is the topology we have, and now if we assign multiple subnet, let's say this side 192.168.10.0/24, one subnet, and router this side we need to use another subnet 10.1.1.0/24. This side 11.1.1.0/24. This side 192.168.20.0/24. So router each side we have a different subnet, and from this subnet we need to allocate the IP address. For example, for this PC we put 192.168.10.1. For this interface 192.168.10.10. This one 10.1.1.1. This interface 10.1.1.2. So this is part of your network design. You need to assign the IP address for each of the interface. Then in here 192.168.20.10. This side 192.168.20.1. So these are the IP address allocations we have. And we get to configure all these IP address inside this interface. Okay. Now, once you assign this, allocate this IP address, now we need to configure each of the IP address. Let's have a look how to configure this IP address. So I'll start from my PC. PC IP address is 192.168.10.1, and PC default gateway will be this interface IP address. Okay, that's the gateway. That's the door. Done. I'll go to these routers, CLI. I'll put no, enable, config T, interface gig 0/0, IP address 192.168.10.10, mask 255.255.255.0. Say no shut. Right, we configured this interface. Now let's move to this one. interface gig 0/1, IP address 10.1.1.1, 255.255.255.0. So we have used all /24 network. So these routers, I have configured this IP address, and I also put no shutdown command. Now I'll move to my second routers. I'll do the same configurations. I'll say no, enable, config T, host name will be R2, interface gig 0/1, IP address 10.1.1.2, mask is 255.255.255.0, no shut. After that, I have other interface, which is gig 0/0. IP address is 11.1.1.2 and put no shut. Now my second routers, I have configured my interface. Now let's move to the third one. I'll go to CLI and we'll say no, enable, config T. We can change the host name to R3. Interface, at first we check the interface, gig 0/1. This is the port number. Interface gig 0/1, IP address 11.1.1.3, 255.255.255.0. No shut. Now interface gig 0/0, IP address 192.168.20.10, 255.255.255.0, no shut. So you've configured this interface as well. All the interface should be up, right? And now we need to configure the PC IP address. So they are the standard configurations, like all the interface, all the device, they need to have a IP address. Gateway 192.168.20.10, right? For this PC, gateway will be this one. Now, so far we have done all the IP address configurations. Now, if we'd like to ping from this device, if we'd like to ping other device, it will not work because we need to configure routing. This router don't know anything about, this subnet or this subnet. So we need to configure routing in here. So when you have many routers, that time it's easy to configure the OSPF. Now we go to router 1 and we start to configure OSPF from here. But before that, we can test, we can try to ping. Let's say I have to ping this router's IP, which is 10.10. It should be working because they're in same subnet. Now from this router, if you'd like to ping the other one, it will work as well because they're in same subnet. But if I try to ping 10.1.1.2, it will not work because this PC don't have any routing over there. It will not work. If we try to ping something other side, ping 192.168.20.1, it will not work. It says destination host unreachable because we do not have any routing. Now we need to configure the routing. I'll go to my router 1. This one, exit from here. I'll change the host name at first, R1. So how to configure OSPF? Let's have a look. At first we say router OSPF1. This one is a process. Process means in entire area you can have only one process. For example, you can select any number 1, 2, 5, 10, any number you can choose. But all the process should be same in one area for one kind of routing. So router OSPF1, this is the process. Then we say router ID. This is router 1. I'll put 1.1.1.1. This is, you can make up any number, but has to be in this format. But this is router 1. That's why I put 1.1. So it's easy for me to understand that this is related with router 1. And network, with my router 1, I have this subnet and this subnet. These two subnet connected in here. So I'll say network 192.168.10.0. After that, wildcard mask 0.0.0.255. And then we are going to configure only one area. So first area will be area 0 and hit enter. After that, I'm going to add the other subnet, say network 10.1.1.0 wildcard mask area 0. So you configure process, router ID, and add that network with the wildcard mask with the area informations. So same way, we'll be able to configure other two routers. So when you configure in here and there, then these routers, they will make the neighbor relationships. They'll communicate with each other. They'll send the link listed advertisement. They'll send the hello message as well. In this way, they'll maintain the routing and communications. I'll go exit from here. Router OSPF1, router ID, network 192.168. Oh no, we have only 10 and 20 networks. So we put 10.1.1.0, 0.0.0.255, then area 0. And then again, we're going to add other one, which is 11. Area 0. Yeah. So we have added 10 network, and also we have added 11 network. Now I'll move to router 3. I'll do the similar configurations. I'm going to add 11 network and 20 network. These two subnet I'm going to add in this router. So I'll say exit from here, router OSPF1, then router ID 3.3.3.3, network 11.1.1.0, 0.0.0.255, area 0. And then we have another network, say network 192.168.20.0, 0.0.0.255, area 0. So we have added all the network. So in this way, this routers knows about these two subnet, middle router knows about these two subnet, and this router, it knows about these two subnet. Once they know this subnet, they will actually exchange the database informations. In this way, now these routers will have information about these routers and their subnets. Okay, and you can already see the message is saying that is neighbor the load up. So loading to full, that means full neighbor relationships happen. Now, if I go to my middle routers and if I apply some command, say show IP OSPF neighbor. So this one will tell me my neighbor. So I have two neighbors. One is, by looking at the router ID, I can say this is my router 1 and this is my router 3. I'm in the router 2. So I have two neighbors. I can say show IP OSPF route, show IP route OSPF. See, it's clearly saying that I have routing to 10 network and 20 network. So I'm in the middle router. So from here, I can go to this network and also that network. If I do show IP OSPF protocol, show IP protocol actually, show IP protocols and hit enter, is saying that we have OSPF routing protocol and this is the process number 1 and I'm in the router 2. This is the router 2 ID. We have maximum 4 paths and these are the subnet we have. This is incorrectly one subnet added, but other than that, we have these two correct subnet. And we have, this is the all router ID, administrative distance. So you can see many informations with these protocols. And the command show IP OSPF database and hit enter. Now database, we have router ID. We have 1, 2, 3. And we have, this is the router link state database. Database means it will have a other routers informations. We can see that this router 2 knows about router 1, router 2, router 3, all the advertisement. Different types of router link state advertisement, network link state advertisement, summary network link state advertisement. So you can get many informations. So this is the OSPF related things, but let's say now if I go to these routers and I want to know the routing information, show IP route. If I do show IP route, it will tell me that I have routing to this subnet and also this subnet. So this subnet, and we can see this is the subnet we have routing, and 110 is the administrative distance and 2 is the cost. So this is the link cost. If I go to that subnet, so it has one more extra link. So cost is 3. So basically 1, 2, and 3. Now from this router, if I have routing, so if I'd like to ping 192.168.20.1, let's say, I'll be able to ping. See, I can ping now because I have the routing. Now from this PC, if I'd like to ping, command prompt, ping this 20.1. Now see, it's working. So OSPF dynamic routing protocol, you do not need to specify which way traffic will go. So traffic will find out the path and then it will send the traffic over there. Even if you have multiple link, it will find out the best path, and based on that, it will send the traffic to destinations. Another important things I have that is how to check the hello and date interval. So if I'd like to see hello and date interval for router 1, then I can apply show IP OSPF interface. So it's showing me that gig 00 interface, which is this one. And we can see the router ID. And in here, we can see the hello timer and date timer. So in OSPF, all the routers should have, same hello timer and also same date timer. If hello and date timer mismatch, router, they will not perform the neighbor relationships. So if I go to these routers, I'll also check whether it's same or not. Show IP OSPF interface. And this is, we're looking at gig 01, right? Yes, gig 01. Look at that. It's got the same hello message, hello timers and date timers, 10 seconds and 40 seconds. So in OSPF, if two routers need to make neighbor relationships, then hello and date interval need to be same. And router ID, remember previously we configured the router ID. So this router ID is 2.2.2, and this router ID is, this one is 2.2.2.2, this one is 1.1.1.2. So router ID need to be different, okay? Because that's their unique ID. That's why it need to be different. If router ID is same, then OSPF router, they will not make any neighbor relationship. And if OSPF hello and date timer, if they are different, then router they will not form the neighbor relationships. If they don't form the neighbor relationships, then OSPF routing protocol will not function. So these things we need to remember.